So, so now more homework problems. You see, you really can have a lot of fun doing this. Suppose that the vector u is equal to -2 and 4, and the vector v is equal to 6 and 1. We're supposed to find u plus v, u minus, that's a big minus, minus v, and 2u minus 3v. This is a piece of cake, and especially now that you know how to do like addition in the complex plane. Basically, it's component-wise. Here's the, I suppose you could think of these as the x's and the y's. U plus v is going to be this. This is going to be -2 plus 6 and 4 plus 1. On a good day, this is the vector 4 and 5. Piece of cake. U minus v. The biggest mistake students make when subtraction is they don't complete the subtraction on both things. U minus v is going to be, I suppose I'll put this here, U plus v. U minus v. Okay, so carefully, -2 minus 6 and 4 minus 1. This is -8 and 3. Now, okay, so this is just really easy. If you've read your book, even in the, oh, Mr. Stinkowl, stop that, bad boy. Now, if you have read your book at all, you won't have any trouble doing this. And if you haven't, Mr. Stinkowl will get you. Okay, so let's do this last one modestly, carefully. It's not really any harder, but we'll be methodical. 2u minus 3v. 2u is going to be 2 times -2, 4. This is, remember, so 2 is a scalar. It's just a number. It multiplies inside. So this is going to be -4, 8. So this is 2u. I'll put 3 minus, actually what I'm going to do is I'm going to do plus minus 3v. I'm keeping the minus with this just to make sure I distribute everything correctly. It'll go exactly the same way. Minus 3 times v is minus 3 times 6 and 1. This is minus 3 times 6 is minus 18. Minus 3 times 1 is minus 3. So what I'm really doing is 2u plus -3v. I'm adding these together component-wise. This is going to be minus 22 and 5. Incidentally, this freaks some people out sometimes, but don't let it. Remember that 5 minus 3 is 2. 5 plus -3 is also 2. Here's why I like doing this. 3 minus 5 is not 2. However, -3 plus 5 is 2. If addition is commutative, it works backwards and forwards. Subtraction does not. Whatever way that you like this, it's okay as long as you get the right answer and you're not using your psychic powers. But this works for me. I know a lot of students say that this drives them crazy. Okay. More problems that you will love. Okay, for this one, we're going to let u equal, and that's a really ugly u. We're going to let u, okay, and actually somebody's gone, dude, that's not a u. What's wrong with you? This is a Greek letter mu, and we use it in mathematics all the time. And the fact is, they are really used in your book, and in almost in anybody's book, but as a mathematician, I'm using mu, so getting used to it. That was funny, come on. Okay, so u is equal to I minus 2j. That's an ugly 2. V is equal to 3I plus j, and w is equal to minus 4I plus j. I'm going to put down what these things are actually equal to. It doesn't really matter. This is just the component form of this. This means the same thing as this. This is 1, negative 2. This is 3, 1. And this is negative 4. That's a terrible 4. And 1. And you should be able to recognize these as being the same thing. Okay? It's important that you can. We're supposed to find 1/4 of 8u, or mu, plus 4v minus w. Once again, this is a simple piece of cake. Do it piecemeal. Forget about this right now. Let's figure out what each of these terms are. So 8 times 1, negative 2 is 8 times 1, which is 8. 8 times negative 2 is negative 16. 4 times v, which is 3, 1. This is 4 times 3, this is 12. 4 times 1, this is 4. So now, you'll notice I'm lining these in columns because I'm going to add them. But so this minus sign, I'm going to do this. I'm not going to subtract w. I'm going to add negative w. And I'm just going to add them straight down. So negative 1 times w is negative 1 times minus 4, 1. This is, I forgot my equal sign there. Negative 1 times negative 4 is 4. Negative 1 times 1 is negative 1. Easy breezy. We're going to add things up in columns. So we're adding these, and then we'll take care of the 1/4. So 8 and 12 is 20. This is, and I'm going to put this up over here because we're going to run out of room. This is 24. Negative 16 and 4 is negative 12. Negative 1 is negative 13. Now, through the magic of color, we're going to remember that we have this 1/4. And this can go inside. It's just a scalar. This is 24 over 4, negative 13 over 4. This is 6 and negative 13/4. Clean up this a little. In vectors, fractions are okay. They show up all the time. So this is it. This is easy and kind of fun. Okay, so the next problem are going to start to be problems that are going to require a little bit more thought. So, Mr. Producer, why don't you shut off so I can clean this up and we'll start fresh.